Hello, everyone. We'll be starting with the session now. Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 12B. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to 10th International Congress on Information and Communication Technology ICICT 2025 London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18 February in London, UK, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 6 presentations, and each presenter will be given 12 minutes for the presentations and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for the session. Dr. Sheng Lung Peng. Sir is a professor and the director of Department Creative Technologies and Product Design in National Taipei University of Business, Taiwan. His research interests are in designing, analysis of algorithm for bioinformatics, combinatorics, data mining, and network areas in which he has published over 100 research papers. Welcome to the session, sir. Would you like to share a quick opening remark with us? So would you like to share a quick opening remark with us?
Sir is on mute.
Sir, you are on mute. Can you please unmute yourself and give the opening remark?
Yes.
Yeah.
Yes, I'm Shen Longpeng from Taiwan. Yes, everyone is welcome to participate in this section for presentation. Yeah, I wish all of you have a good presentation. Thank you.
Thank you so much, sir. So I would also like to take a moment to introduce you to our session chair, Dr. Deepak Mane. Sir is currently working as an associate professor, Vishwakarma Institute of Technology, Pune, India. He has 17 years of teaching experience. He has written books on machine learning, fundamental of programming languages, and principle of programming languages for computer and IT students. His main research work focuses on machine learning, deep learning, and supervised clustering. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Thank you, ma'am. And eagerly waiting for the presentations. Welcome all for this ICICT 25 International Conference. Thank you.
Thank you so much, sir. So now we'll be moving on to the presentations. First, we have Robert Johnson to present the paper titled Artificial Intelligence Tools for Condition Monitoring of Mechanical Processes. Are you there?
Yes. Good morning, everyone.
Morning. You may please begin with your presentation.
Yeah, I'm going to share my presentation.
We can see your screen. You may begin now.
Okay, thank you, everyone. This is a joint work between some colleagues from other universities and the supervisor, Professor Fu Huomanchu, and another colleague from the School of Information Management and Engineering in Shanghai, China, and so Osaka, Japan, and Professor Simani from the University of Ferrara. So this is a more general introduction to the problem, which is summarized in the paper, which is focused on the monitoring of mechanical processes, and in particular, I'm describing an application concerning a wind turbine. So I will briefly review the state of the art, and then I will show a brief description of the problem with the model with the solutions provided, and some results and discussion. So it's quite important for the development of efficient and cost-effective monitoring methods for mechanical systems, and in particular wind turbines. And we, and in particular, and most important, their blades. So it's something that we are considering here. So we adopted an auscultatory approach, which means that we are acquiring the audio data from these processes, and by using convolutional neural networks, and so a signal processing approach and a signal monitoring, we are trying to determine if we are able to diagnose these mechanical processes. And in particular, we are using audio-generated spectrograms from wind turbines. So the state of the art concern these mechanical processes, and also this approach can be applied to more general cases, not only to wind turbines, and specifically to their blades, because in general, mechanical processes, and when you are acquiring for example, the vibration signals, they are contaminated by noise, which is quite complex, and especially in the signal processing, but also in image processing area, it's quite difficult to extract the full features. So we proposed also a noise reduction algorithm, which tries to eliminate these uncertainties. So because there is a common problem is the ineffective use of audio data, because normally audio data is contaminated by noise, and so which this noise is hiding the faults affecting, for example, the process. So another step is the recognition accuracy, which means that we need to maximize the effectiveness of this approach, which normally is affected again by the noise. So normally the noise is reducing the accuracy of our approach. So in order to simplify the description, because we need also to take into account the time schedule. So normally we are coupling the acquirement of the noise or the signal in general with a PLC, because normally you have, for example, a SCADA system which acquires the data, and then another important problem is represented by the correct labeling of your data. So it means that you need to understand the cases that these signals are covering, and these data are fed into a neural network in order to train it and then to validate the approach. So the second important point is the reduction of the noise affecting the data, and then the feature extraction. And again, together with the, as is indicated here by the points 2 and 3, with the noise reduction and then the feature extraction, we are going to train our complex or convolutional neural network. So we are adopting a deep learning approach, which is specifically used for the monitoring of our system. Okay, this is a schematic diagram of our approach. So we have the collection of the data. The data are synchronized using, again, the PLC, and sometimes the PLC can help you in order to for example, in the labeling, because especially for the case, for example, with very specific conditions of our plant or our general process, the PLC can indicate, for example, that these data are reliable. So again, it can help you to categorize this data. And then we have the feature selection and then the application to a neural network, and then which is mainly used for the problem of, or the task of noise reduction. And then by using, for example, spectrograms, which is a possible approach, we are training a second neural network, which is used for the fault, for example, or the monitoring, the specific monitoring of our system. So in summary, this scheme has three modules. It consists of three modules. The first one is the audio data collector, which also determine or enhance the wind turbine operating data monitoring, and it is constituted by a PLC, and which or it can be also consist of for example, a SCADA system. And then we have a second module, which is represented by a noise filtering module. I will show later a few more details, because some also of the results are quite confidential, because are coming from a specific mechanical process, which is under we're trying to provide a patent for it. Is quite again is still quite confidential. And then we have a diagnosis module, which tries to extract from the audio data the faults, and in order also to detect these anomalous patterns. So more specifically, we have the data audio collector. It represents a key module, because in some cases the noise cannot be effectively eliminated by a noise reduction. So in some cases, again, the PLC monitoring can help or suggest which kind of noise can be reduced, or indicate that also the reliability of your data. So in this case, the audio collector is activated, and a database is constructed accordingly. So the noise reduction module is trained, for example, using some noise already available. I will show you later in the results that the noise can derive from different environments, and these methods can be applied also in the time, in the frequency, in the spectral domain. Another important process is the principal component analysis, because it's used to reduce the dimensionality of the overall system. So is quite important in order to provide an efficient screening of the effective feature. And then we have the monitoring system. So the monitoring system is represented by a neural network. And another important point is that is represented by the complexity reduction. Because of course, especially if you want or you aim to implement it in a real-time system, you need to you obtain a less complex model, and especially to remove, as is indicated here, redundant parameters. So and to improve the model viability. So we are trying to remove the redundant parameters from the convolutional layer and to move to the fully connected layer. And especially with some experiments, we are able to remove also some cells that were not essential in our network. So normally, in order to, in this process, in order to reduce the complexity, we
Sorry to interrupt you, but you have 2 minutes to conclude your presentation.
Okay, yes, thank you. So by a first tuning it was implemented with traditional techniques, we moved to a fine tuning and we obtained good results. So the simulation results were obtained by using a data set which is available from the web, and it was used for the noise reduction step. And then in order to validate the performances, we use the signal acquired from a real system. And we used also some performance indices, which are normally used for the exploitation, for the validation of audio signals. And then the system, this is a description, we used the horizontal axis and vertical axis wind turbines, which were available at the Dyson Institute. And we got very interesting results because we can here see that we had a final accuracy of the 94% and also an FA1 value of 94%. So it's very important achievement. So in order to conclude my presentation, we tried to develop, and I tried also to present a method for extracting the feature from the audio data and to use it for monitoring a mechanical system. Which the process which I proposed was can be applied to general processes. And we show some interesting results. Of course, we need to perform some other experiments, especially on more realistic processes, but I think it represents a very interesting application to real world scenarios. Okay, thank you for your attention.
Thank you so much for your presentation. Sir, do you have any questions?
Yes, I have some question. Can you tell me your contribution? What is the novelty in your system? Novelty, your contribution.
Sorry?
Yeah, can you tell me your contribution in your proposed system? Novelty, outcome finding.
Oh no, the outcome. Oh, the outcome is the it needs to tell you if the status, if the wind turbine is faulty or is healthy. I don't know if it was your question.
Okay.
It can tell you also a probability of your failure, depending on if you are interested, can be also represent the reliability of your system. Is quite interesting, I think, is the fault probability as well.
Okay.
Okay, thank you. Sir, do you have any questions? I guess no questions then. So we'll be moving on to the next presentation.
Thank you.
Thank you. So next up, we have Najuri to present the paper titled Characteristics of Handicraft Business and the Integration of Lean Manufacturing within these units in the Medina office. Are you there?
Hello, good morning, everyone.
Yeah, you may please begin the presentation.
Okay, I will share my screen. If you can accept, please.
Yeah, you can share your screen now.
Okay. Okay. You can see my screen?
Yes, we can see your screen. You may begin now.
Okay. So I am Nada. I am a PhD student in Morocco. So my topic is about implementation of lean manufacturing tools in handicraft companies. So today I will present some results about this topic. So just to introduce that in this slide here, so we were driving into a crucial topic for Morocco economy, the handicraft sector. So it's a key economic and critical asset. So it preserves culture and traditional craftsmanship. It creates jobs and support local economies. And also it boosts tourism, a major economic driver. But it faces major challenges, such as lack of efficiency in production. Scaling up is difficult, limiting growth potential, and rising competition. So both locally and globally. The big question in our topic is how can lean manufacturing boost productivity without compromising authenticity of artisanal companies. So that's what we were here to explore. So let's get started. So in this slide, I would just to show you some key numbers that highlight the impact of the handicraft sector in Morocco. So 90 billion in revenue, a significant contribution to the economy. 20% of Moroccan population is employed in this sector, showing its importance in job creation. And it accounts for 8% of Morocco GDP, making it a major economic pillar. Some of the largest sectors include pottery, woodwork, and traditional weaving, dominating the industry. In terms of product, clothing, leather goods, and carpets stand out up as top categories. So this figure underlines both the potential and the challenge of Moroccan craftsmanship. And the big question, how can we optimize and modernize this industry while keeping its essence intact? So handicrafts, it's an industry before industry. So before industrialization, craftsmanship was the backbone of production. The only way things were made. Every product was handmade, unique, and rich in human skills. Then came mass production, bringing efficiency and skill, but at price, loss of uniqueness, diminished human touch. So what the challenge today? Traditional craftsmanship must adapt the goal, leverage lean principle to enhance efficiency without sacrificing authenticity. So lean manufacturing is all about eliminating waste, improving quality, and reducing costs. It has already transformed industry like automotive, aerospace, and SME. So why not apply it to handicraft companies? So why are these tools necessary? They are necessary to the more reasons, such as a more structured and flexible workflow, better responsiveness to market demand. And I can tell that the best lean tools for the craft sector, I talk about VSM, value stream mapping, in order to identify waste and optimize flows, 5S in order to organize workshop for efficiency, Kanban in order to streamline production and avoid unnecessary stock, Kaizen in order to ensure the continuous improvement and skill enhancement for artisan, standardization and training and the transfer of knowledge, and finally quality at source in order to prevent defects rather than fix them. So lean can improve craftsmanship by keeping the traditional alive while making it more competitive and sustainable. So to understand the reality of artisanal entreprise, we conduct a survey of 17 business in Fez Medina, a historical hub of craftsmanship. We analyzed 5 key areas to get a comprehensive view So this 5 key area are especially general business information in order to understand the structure and operation of this enterprises, human resource and workforce in order to examine the skills, challenge and workforce dynamic, production and quality management, so to assess how production process are managed and quality is ensured, lean manufacturing awareness in order to identify if and how lean principles are known or applied, and finally continuous improvement practices in order to explore whether this business embrace a culture of ongoing improvement. So this methodology allowed us to pinpoint strengths, gaps, and opportunity to help artisanal enterprises evolve while preserving their authenticity. So now I will present the key finding. So after this survey, we find that the main sector, especially in Fez, are pottery, sleeve, leather, clothing, and metalwork. And the ownership 80% as family owned, reflecting strong traditional roots. So, and the most business have fewer than 20 employees, highlighting their small scale nature. Women in workforce only 10%, showing a significant gender gap in employment. And yeah, this is also many businesses have been operating for decades, reinforcing their deep-rooted expertise. Organizational structure vary, but most follow a simple family-based hierarchy. Specialization are diverse, but dominated by traditional craft like pottery and sleeve. Capital is mostly self-financed, which can limit growth opportunity. So this insight showed the strength and challenge of artisanal business. And the question is, how can we modernize this structure while keeping their essence intact? So the key challenge in traditional handicraft business are especially that traditional craftsmanship is rich in heritage, but it faces major hurdles. So let's break them down. Lack of formal management structure. Most business operate informally, often within family setting, leading to inefficiencies. Low automation and process standardization. So production remains largely productivity, limited market reach and scalability, so a small scale production and lack of access to modern marketing tools make it hard to expand beyond local markets. Informal training, so skills are based down trough experience, not structured training, leading to variability in quality and expertise. So this challenge hinder growth, competitiveness, and sustainability. The next step is to apply lean principle to overcome these barriers while preserving authenticity. So handicraft production is manual, time-consuming, and inconsistent. Process like structure, standardization, and waste control. So lean principle can change that. By applying lean manufacturing, we can reduce waste, minimize defect, overproduction, and inefficiencies, standardize workflow, ensure consistency without losing craftsmanship, use visual management in order to improve organization and reduce errors, implement piece-by-piece flow in order to enhance efficiency while keeping production flexible. So the top image represents an industrialized lean system. The bottom image reflects traditional craftsmanship. To challenge how can we merge the best of both worlds without losing authenticity. So even without formal lean training, many handicraft business are already applying some lean principle, but in an unstructured way. So the key finding in this part that 60% track basic performance indicator. They measure productivity, but with no clear framework for continuous improvement. 50% unknowingly apply piece-by-piece flow. They produce in small batches, but without structured flow optimization. Visual management is used, minimark workstation for organization, but lack standardized rules. Standardization exists, but informally, so processes are passed down verbally or trough experience, making them and consistency. So artisanal business already have a foundation for lean, but without proper structuring, this effort remain inefficient. So how can we make handicraft more efficient without losing their essence? So the step one is about training program. So teach artisans sample lean tools to improve efficiency while respecting craftsmanship. Step two, process standardization. Implement structured workflow without limiting creative freedom. Step three, digital tools introduce a basic tracking system to monitor production, reduce waste, and optimize time. And finally, the step four, sustainability focus, reduce material waste and optimize energy consumption for a greener, more sustainable production model. By integrating this step, we can boost productivity, reduce costs, and maintain artisanal authenticity, and making handicraft more competitive in today's market. So the next step of my work is moving from theory to action. Now that we were explored the lean handicraft model, what is the next? Real implementation of lean tools. Start applying lean principle in workshop and production process. Train artisan and integrate standardization without limiting creativity. Observation and adjustment of processes. So monitor how lean is impacting efficiency and identify area for improvement. Fine-tune processes based on real-time feedback from artisan. Post-implementation simulation and measure productivity gains and the waste reduction. And finally, use data-driven insight to scale improvements across more workshops. So this is a continuous improvement cycle: implement, observe, adjust, and optimize. So thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Yeah, I have one question. So this is all about analysis. So you have taken the data and you did some data analysis on that data. So can you tell me what you found when we are seeing the analysis? So we are trying to extract the knowledge. So what you found when you did the analysis on this data? Outcome like that, what you found?
So when we have done this data, we find several problems. So in handicrafts, as I presented, there are a missing of training program, a missing of understanding the tools of continuous improvement and how can implement this really in their companies. So the objective is working on this aspect, such as training and help them to understand the lean manufacturing and how can implement it in their companies. So we are working on this actually, and maybe can be presented in other articles.
Okay. Okay, thank you, ma'am.
Thank you. Thank you.
So I guess we don't have any more questions. So we'll be moving on to the next presentation now. Next, we have Ubaid to present paper titled Comparative Analysis of Parameterized Action Actor Critic Reinforcement Learning Algorithms for Web Search Match Plan Generation. Are you there?
Hi there, I'm here.
Yeah. You may please begin with the presentation.
Okay, I'm just busy sharing my screen.
We can see your screen.
Perfect, thank you so much. So good day everyone, my name is Ubaid and I'm doing a presentation on the research that myself and Dr. or Professor Tim Narinda worked on, which is the comparative analysis of parameterized action actor critic reinforcement learning algorithms for web search match plan generation. So just the outcome of this presentation, we'll go through an introduction, a match plan generation overview, reinforcement learning fundamentals, value and policy-based reinforcement learning methods, parameterized action within the actor-critic algorithms, and the simulation setup and conclusion and future works of the research that we have conducted. So just a quick introduction, the evolution of search engines, advances in the index design, storage and query evaluation have improved in efficiency. However, rapid growth of web documents make traditional processing methods impractical. Hence, match plans are used to help balance results and response times. Some of the challenges within match plan generation, varied matches cause unpredictable data distribution, and rigid designs require frequent customization. So as more data and as users search, additional customization is required in order to retrieve the relevant results. The reinforcement learning approach that we are using is derived from Liu. He reframed match plan generation as a reinforcement learning problem and introduced parameterized action soft-actor critic, which is one of the algorithms that we are also using for adaptive optimization. PASAC integrates parameterized actions with soft-actor critics entropy framework for stable decision making. And then we will be comparing alternative methods, and those are the greedy actor critic for faster convergence and improved stability, and then the truncated quantile critics, which reduces overestimation bias. And the study evaluates those three algorithms over 5,000 episodes to assess the policy learning effectiveness, convergence speed, and maximum reward challenges. Studies show that web search often acts as a starting point in the information seeking processes. So we feel that this research plays a big and vital role in the search engine optimization mechanism. This is an overview of match plan generation. Document representation in search engines. Documents consist of multiple fields derived from various sources, and each field has an inverted index storing keywords with posting listings. So that means that based on huge text data, it extracts keywords and then stores those keywords for querying when the time comes. Query classification. The system assigns the query to predefined types. Match plan generation guides document scanning based on match rules, defining ranking constraint and stopping criteria. So it needs to have a stopping criteria, otherwise it will continuously pull up information. Document merging and ranking. So there's various mechanisms to not just to retrieve the data, but to also re-rank it. And this helps with filtering and improves quality for the user when they're searching. The key thing that when it comes to match plan is balancing speed and quality. Simple queries are quick and match index documents quickly. Complex and rare queries require deeper scanning strategies, and machine learning models refine candidate rankings for optimal search results. This is just an example of a match plan. This is the Bing's, the search engine from Microsoft's example. And over here, you can see they're busy ranking and pruning the documents, and then they're matching it, and then they store in the documents. And then over here, you have the match plan with the stop quota, which is important, as I mentioned earlier. So reinforcement learning fundamentals. Just a recap, reinforcement learning overview. Reinforcement is a subfield of machine learning that teaches agents to act in environments to maximize cumulative rewards. Unlike supervised learning, reinforcement learning does not rely on labeled data. Instead, it learns through interaction with the environment. Core components of reinforcement learning: the agent and environmental interaction. At the time, the agent observes the current state and selects an action based on the policy. The environment responds by transitioning to a new state and providing a reward. The return calculation: the agent aims to maximize the expected sum of rewards over time, represented by the return, and the disconflict determines the importance of future rewards. Policy and value functions. Policy is a strategy of mapping states to actions, which can be deterministic or stochastic. A value function can have a state value function as an expected return from states, and an action value function, which is an action value from taking an action. And then the reinforcement categories, you get value-based, which is Q-learning and STARSA. It's a estimated value function and derived from policies. And then you get policy methods, which is optimize the policy directly using gradient ascent. And then you'll be looking at actor-critic, which combines both approaches for efficiency. Value and policy-based reinforcement learning methods. Actor-critic combines both of those approaches, which is the key function of this research that we delivered. The actor updates the policy while the critic evaluates the actions. Now I'm just going to break down the three algorithms that we've used. The soft actor critic maximizes exploration using entropy regularization and balances exploration with exploitation for stable learning. Greedy actor critic is practically the opposite. It uses cross entropy to prioritize top actions, ensuring policy improvement, and prevents policy collapse by maintaining entropy in the proposal policy. So it maximizes the reward in other instances. Truncated quantile critics reduces overestimation bias by truncating quantile critics, so it has multiple critics and practically uses the average of those ones, and it enhances the stability in the reinforcement learning models. We've introduced the parameterized action in the actor critic, largely because queries and the search results are quite fast. So using a parameterized action helps us improved the results for high discrete action spaces. So parameterized action consists of a discrete action with an associated continuous parameter vector. An example, a football playing robot, it will kick, and that is the parameterized action, and the output is power and direction. Passing will have a different outcome, which is target location, and running, speed and direction. So this is just an example of different parameters with different outcomes. The challenges in using reinforcement for machine generation. Hybrid action space requires both handling discrete and continuous actions simultaneously, complex environmental high-dimensional query representation, and dynamic states with continuous valued features. Sparse rewards, limited early feedback makes training difficult, so the more the agent trains, the better the response it will have. So hence the limited feedback for training, unless it's training a little bit longer. Then the parameterized action within the actor critic framework. So we extended the traditional soft actor critic, to support hybrid action spaces. The key modifications was a dual actor network. Separate branches generate discrete and action spaces. Unified critic network evaluates combined Q values for hybrid action and state representation, sharing shared layers to encode state efficiency. The advantage of this, it enables effective decision making in complex hybrid action spaces. So the simulation and the setup. So the evaluation of those three actor critics, we assess adaptability and efficiency in high-dimensional access spacing in decision making using two games. One game is called the platform, as you can see over here, and the goal. And these games have discrete actions with continuous parameters. The hyperparameterized tuning, we use Microsoft neural networks. So they made the hyperparameters so that we didn't have to do it manually. And then reproducibility, we used the common code base based off the original work and just modified it for the greedy actor critic and the truncated quantile critic. And then we've measured the following mean training incentives.
But you have 2 minutes to conclude your presentation. Sorry to interrupt you, but you have 2 minutes to conclude the presentation.
Okay, perfect. Thank you so much. So the performance metrics are the mean training incentives, fine evaluation scores, and time to complete 5,000 episodes. So the platform game, the actions are run, hop, leap, and the goal is to reach a target, and there's 9 features. As you can see, the greedy actor critic outperformed in both time and evaluation in comparison to the soft actor critic and the truncated quantile critic. And the robot soccer goal, which is to kick, shoot, or left to right, and it has 14 continuous features. The greedy actor critic, in terms of time, was the best, while the truncated quantile critic had a better evaluation over this game. It is therefore concluded by us that the greedy actor critic has a much better performance in terms of time and average evaluation. So the summary of findings compared to the soft actor critic, which was the original work, greedy actor critic and truncated multi in action spaces. We observed fully observable environments, no networks required, and the benchmarks were the two games. The key takeaways was that Pagak consistently outperformed soft actor critic and truncated quantile critic with the fastest training times for both the games. It's the most stable and efficient decision making in a hybrid action basis, and truncated had a strong returns, but was slower than Pagak, and soft actor critic lagged behind in both speed and efficiency. And then just to wrap it up, the future directions of the work, we can combine hybrid strategies by combining entropy regularization with truncated-based approaches, generalization, testing across diverse environments in real-world applications, and enhancing stability and performance in hybrid action spaces. Thank you for your time, everybody.
Thank you so much for your presentation. Sir, do you have any questions?
Okay, elaborate about your contribution.
So my contribution was we took the original work, which was comparing the parameterized soft actor critic with deep deterministic algorithms. We expanded this work by introducing greedy actor critic, or parameterized greedy actor critic more specifically, as well as introducing parameterized action truncated quantile critics to expand on the work that was done previously.
Okay. Okay, thank you.
Thank you. Sir, do you have
Thank
any
you.
questions? Okay, I guess no questions then. So we'll be moving on to the next presentation now. Next,
Thank
we
you so
have
much.
Amalia to present the paper titled Interactive Websites for Sustainable Pharmaceutical Governance and Collaboration. Are you there? Amalia, are you
Yes,
there?
yes, ma'am.
Yeah, you may please
Yeah,
begin.
can you hear me?
Yeah, you can share your screen and you may begin with the presentation.
All right, sure. Share.
Yeah, we can see your screen. You may start.
Hold on, yeah. All right. Hello, everyone, and good day. So my name is Amalia Muklas. I'm from University Kuala Lumpur, UniKL. So this research is actually a combination, collaboration, several researchers from University Kuala Lumpur and also the Asia Pacific University of Technology and Innovation. So today I would like to present my research about interactive websites for sustainable pharmaceutical governance and collaboration. So basically this study is to explore how the pharmaceutical websites can improve governance, compliance, and collaboration with external parties and stakeholders. Okay, so the pharmaceutical industry is actually, they are highly regulated, okay, and they not just influence the public, but also several areas involved like economy and also environment. So the sustainability system for this area is very, very important. to ensure the long-term efficiency, transparency, and also for the responsibility of the business practice. So, however, when I conduct this research, I noticed that the digital transformation for this area is still struggles, especially in their website. So this is actually why the motivation started for this research, where I found that this is a real world challenge where when I attempt to reach them, I noticed that they have poor websites. So this make them a bit difficult to collaborate and having some compliance in terms of their digital content. All right, so the challenge that I identified is that they have a poor website. And the pharmaceutical website itself fails to foster collaboration. So which means that other parties will have limited accessibility to their contact information. And their website also very static and lack of interactive features like a real-time engagement with outside parties. So this study is to highlight the gaps where we propose ways to overcome or to improve the website itself. So this involves the digital governance through interactive website. So this study would like to examine the role of the website in pharmaceutical governance and identify their inefficiencies that make them having difficulties to collaborate with the outside parties, especially the academic researchers. And this study also proposed some improvement for their usability improvement and also for their transparency. Okay, the method that I use for this study is an experiential observation approach. So this is actually a systematic process where if you can see from the flow over here, when I conduct this study, I search the companies, the pharmaceutical companies from these two association, that is MOPI and also the pharma. So these two are association, pharmaceutical association, where the pharmaceutical company registered themselves as a members. So there are about 44 companies under Malaysia pharmaceutical industry and 43 companies under Pharmaceutical Malaysia Association. So we list the company in a matrix, and then we do the checking. So this is when we filter out whether the company is suitable in our research domain. Okay, and then once we have filtered out, we perform exploration on the company's website one by one. We check on the details and what will be the communication system that they use. So first, we will look into whether the website contain inquiry form. So they will allow us to communicate or to inquire what we would like to search from the website itself. So if they do have, then we try out to send the inquiry form to the websites, and we will see whether they reply or not. If they do reply, then we we group them under giving a good response to the outside party. And if they do not reply, my team and I will try to make a phone calls and email the company for our requests, and we check for the status whether they give feedback or not. So from this process, we also look, we evaluate this company, whether they have easy contact information retrievals. Okay, and we also look into their response to our query and how they present the features from the website itself, whether they do have live chat or they provide some automated response or not. So this will be some of the evaluation criteria that we look at from this process. So the findings that we get from this study, we group it into two. So the first group is where we notice some of the company with a good website interaction, and the second one is with poor website interaction. So from the numbers of company that we try to check their website, so we noticed that only two companies that falls under good website interaction, which means over here they do have user-friendly interface, clear contact forms. They provide real-time chat, and they also provide quick response to our query. For example, there's one company, these two companies, they give response to our query. Our response, the response time is between 30 minutes, something like that. So which is quite fast. Okay, and then the second group, that is poor website interaction. So most of the companies, they falls under this second category, which is the poor website interaction, where they only have a static and basic portals, unresponsive forms, and they simply provide general contact details without direct support on that lah. So some of the calls also is unanswered, and often I notice that they routed to the multiple departments, or even in the routed to the HR without direct to the right person. And there are some emails remain unanswered, and I also receive late feedback from them. So these has identified the gap in the digital communication, which we notice will impact on the collaboration matters. So we notice that this hinders in terms of the compliance support, and in terms of the academic industry partnership, in case if the researchers like me and other parties would like to collaborate with the pharmaceutical industry. So this is very set from my team. Okay. And this study also proposed the enhancement on the website, that they could implement a user-friendly and searchable contact database, integrate the AI-driven element like real-time chat, real-time query resolution, improve their website navigations, perhaps with collaboration portals matters, and then enhance the transparency through interactive compliance dashboard. And as for the conclusion, interactive website significantly improve pharmaceutical company and also their governance, which also enhance their usability and also transparency when dealing with other parties. So this will help them to sustain or strengthen their sustainability in the industry. And my team and I suggest that for the future research, it could be integrated with, enhanced further with the AI area to optimize the compliance on the regulatory and also the website itself. So thank you from me, and I would like to answer any questions from your side.
Thank you so much for your presentation. So, do you have any questions?
Okay, ma'am.
Mhm.
In your proposed system, you are saying the data analysis. So what type of data analysis you did?
Data analysis.
Yeah.
Okay, based on the systematic process just now, what I did was it's just like a manual count, because we do like from the table metric just now and in Excel only. So I just notate the evaluation criteria that I have. Then from there I can see whether which company has a good website interaction or not lah. So that will be my only data analysis. So out of the result from the almost 87 companies just now, I noticed only two companies that provide those good website and the response to outsiders. Mhm.
Okay. Thank you.
Thank you.
All right.
So do you have any questions? Okay. So I guess no questions then. So we'll
Thank
be
you, everyone.
next presentation now. Next, we have Sarah to present the paper title IoT-based framework for cholera disease early detection in Yemen. Are you there? Are you there, Sarah? So we'll be moving on to the next presentation. Next, we have Praveen to present the paper title Securing UAV Communications Using Lightweight Cryptography Algorithms. Are you there?
Yes, ma'am, I'm there.
Yeah, you may please begin with the presentation.
Yes. Is it visual, ma'am?
Yes, it is visible. You may begin.
Oh. So my topic is securing UAV communication using lightweight cryptographic algorithms. Before moving to the topic, let me tell you about the current scenario of the IoT devices and the networks related to the communication. Nowadays, unlike previous days, in olden days, the networks used to have different kind of devices which were a standalone type, means they could not be accessed from the remote area. And as the days are changing and the internet era has come, so people have decided to make the devices compatible so that they can be accessible using the internet. So people have derived and developed IoT devices, and now they are using them and in the networks, and they are so much useful that they can be placed in the networks in the areas where it is completely remote, where the human cannot dwell, or they can't go and check the information or do any analysis. So these kind of devices are very much handy nowadays. So these are very much useful for getting the information from a very far away to the place which user is staying. So this kind of devices are called as Internet of Things devices, IoT devices. And coming to my topic, it is securing the UAV communication using lightweight cryptography algorithms. Actually, UAV devices are having a vast applications nowadays. We'll see in the next slides. So before going to that one, let me tell you the contents I'm talking about. The introduction, motivation for why I have taken this topic, and the taxonomy means the classification of the lightweight cryptography algorithms. And later on, I have gone to the experimental setup and implementation, and after that, I have discussed results. And a comparative analysis I have done with respect to the previous works done in this area that we'll see later. So coming back to this introduction, so UAVs are having a vast variety of applications in many of the technical fields. So where it is being used for very much crucial data communication, and people are using them for personal details or personal usage, or so people are using them for the surveillance. Means they would send these UAV devices somewhere in the remote areas, and they will do some kind of surveillance, and these are finding applications in the health sector also. So with this means this scope, it is generating a huge amount of information, and these are very much vital and sensitive data. And in order to be accessible with the person who is sitting far away from there and who wants to have analysis upon the data it is collecting, there should be some device mounted, or the UA itself should be compatible enough to provide the information through the internet. So the UAVs which are based on the resource constraint, means if a UAV is mounted or either it is having the accessibility with the internet, then that is very much handy for the person who is sitting far away to analyze the data it is sending. The problem lies that if when it is generating so much of vital information, sensitive information, there is a possibility of threat from others who are not authenticated people. So in order to overcome this problem, the information which is being transferred or communicated between the user and the drone, there should be some means to secure the information. So there is a possible solution we can get from the cryptography algorithms. But the thing is that the IoT devices are mostly resource constrained, like the power which is means power handling capability, or the memory usage, or the memory present in the memory size present in this IoT devices is very much limited, and the processing capability also very much limited. The reason behind that is that they are confined to a particular or a specific task only. They are not doing a multitask there. They have been assigned a single task. So according to the applications, most of the applications are very much limited. They require a limited, they give a limited weightage to this load to these IoT devices. So that's why these are very much having a very little resources, and moreover they are battery driven. So if you want to enhance this capability also, there is no possibility, because the power source itself is very much limited. So in this way, the data which is being communicated from these devices has to be secured, which I have told already, but cannot be achieved using the traditional cryptography algorithms, because though the cryptography algorithms are promising one, but they are the conventional one which have been derived in olden days are very much resource means they require much resources like memory and power and many processing things for processing the data. So researchers have decided, and they have come to a point that why can't we modify this conventional cryptography algorithm itself in order to be compatible with the IoT devices. So what they have done is they have taken the older one only, but they have changed the algorithm itself in such a way that they don't demand much resources, unlike with the traditional cryptography algorithms, and at the same time they are securing the data. So this is the current scenario right now, and the lightweight cryptography algorithms, in short LWC algorithms, are showing a promising means they're showing a proper security for the data which is being communicated through these resource constrained devices or IoT devices. The resource constrained devices are generally means they are having a limited resources. That's what the term means here. And most of the UAs are using these resource constrained devices. So here in my core work, actually, I have incorporated a resource constrained device and I have mounted that on the drone or UAV, which I'm actually using a drone here as a UAV, and I have mounted the IoT device or resource constrained device. Thing is that I have to communicate with the ground control station and the drone. Ground control station is nothing but the sender one, and drones, suppose we consider that as a receiver one. If you want to send that one, then that security is has to be matched and reached, and at the same time with the limited resources. So that is being done properly and successfully using the LWC algorithms. And the reason why I have chosen this area of research, which points have given me motivation to do this one, is that the UAV, the data which is handled by the UAV devices is very much sensitive and very much vital. So these have to be secured, and moreover, as they are incorporating, most of the UAV devices are flying far away. So most of the devices, IoT devices inbuilt in them, or peripheral devices associated with them, will be having a limited resources. So this cryptography, traditional cryptography, are not promising one, and the LWC algorithms which have been used there, though they are giving a proper security, but there is no proper comprehensive analysis so far. Means altogether, all LWC algorithms have not been brought together in a particular application, and their performance analysis has not been that much extensively done so far. So what I have, that is the reason why I have come to this this field of research. And moreover, along with that one, I have selected a new lightweight cryptography algorithm which has been declared as a finalist in NIST standards last year 2024 by NIST. NIST is the organization which is authenticated and it generally standardizes this cryptography algorithm and more and some other things also. It is located in Maryland in USA. So this has declared ASCON as the finalist of its standardization process. So I have considered also. And implementation of the light on UAV devices and their performance analysis, as I have told now. So it is very much limited. So that's the reason I have selected this research area. And coming to the next one, the classification of LWC algorithms. As I have told that LWC algorithms have been derived from the conventional one only. But the thing is the classification is done in a similar way. Means in a traditional one also, we find that there are symmetric key cryptography algorithms and asymmetric key cryptography algorithms also. The principle which it is using, it is the same. Means in the symmetric key, what we do is that encryption and decryption done by a private key. And in asymmetric key algorithms, we encryption and decryption, one process is done with the public key and another process is done by private key. Here also it is done by the same thing. And in my core research, what I have done is I have taken some of the LWC algorithms for performance analysis on the drone. That we are going to see in the further slides. Now, this is the major classification, and I focused mainly on this symmetric key cryptography ciphers. Cipher is nothing but the cryptography algorithm here. So symmetric key ciphers, and this symmetric key cryptography also I have majorly focused upon the block ciphers, because the block ciphers have proven to be more promising and they're performing. They're giving a bit better results nowadays in majority of the applications. So I have selected some of this, most of the ciphers from this one, and from a tweakable block cipher, I have selected ASCON. I have not gone for the stream cipher because it is less prominent nowadays. The difference between this block cipher, stream cipher, and tweakable block cipher is nothing but that the way they are handling the data. Suppose there is a message of yes.
Sorry to interrupt you, but you have 2 minutes to conclude the presentation.
Okay. So this is the classification which we see here. And I have taken 8 ciphers from this classification, and I have incorporated in the hardware setup. And moving to the hardware setup, which I have experimental setup, which I have taken. This is the experimental setup which I have taken, and one is the ground control station, as I have said, and the other one, the right side, is the drone and its display screen there I have kept there. So these are the two which are getting communicated, and one is using the cipher and encrypting that one and sending to the drone, and the performance analysis of those ciphers are being done, and later on some of the peripheral device I'll show you. This is the flight control of the drone, and this is the Raspberry Pi, which is the IoT device which I was talking about. This is the one which is communicating with the ground control station, and it is mounted upon the drone. And the parameters which I have used for the performance analysis are these are the parameters, and hardware and software parameters: throughput, latency, power consumption, energy consumption, and memory usage, time taken and clock cycles, hardware, software efficiency, and latency. And moving further, so these are the results which I have got from the performance analysis, and for each performance metrics or the performance parameter, like hardware throughput, I have considered 8 of the ciphers, and I have taken 5 different payloads: 20 kilobytes, 40 kilobytes, 60, 80, and 100 kilobytes, and I have analyzed them. And similarly for software throughput, memory usage, and memory usage, hardware latency, software efficiency, power consumption, energy consumption, time taken, and clock cycles. So these are the results. And coming to the comparative analysis, with the previous work I have compared, and previous works what ciphers they have considered, and what are the metrics they have used for the analysis. That is the chart shown in this table. And in my my research, I have considered 8 ciphers and 10 parameters for the analysis. And coming to the conclusion, the same thing which I have told till now, that I have considered eight ciphers, and for 5 different payloads, I have taken 10 performance parameters for the analysis. And from the graphs, we can see that there is no particular cipher which is performing best for all of these performance metrics. And so the researchers can select basing on their application, whichever is their priority. And in future scope for selecting the best cipher, we can go for another algorithm which can select the particular optimal cipher among this one. And coming to the acknowledgement, this project was sponsored by C3I Hub at IIT Kanpur. We are very much gratitude and thankful for the financial support provided by them. The other references and this I conclude. Thank you.
Thank you so much for your presentation. Sir, do you have any questions? Sir, do you have any questions?
Okay, yes, I have one question. How
Yes,
you
sir.
compare your result? I hope the existing approaches are there, and how you compare with the existing?
Comparing results with the previous one, sir.
Yes, yes.
Thing is that my objective was to see bring all of these algorithms in a single particular application, sir. So what I have done is I have considered one particular application and taken all of these ciphers together and applied upon them. So there is a possibility that for a particular, suppose one particular metrics like software throughput or hardware throughput, if you consider all of these them together, so we can side by side, we can see for the same input and for the same device, how they are performing. So this thing I have not found in anywhere in the, means this much a comprehensive way I have not found. So this why I feel like it. Yes, sir.
Okay, so this is your novelty. You can say this is your contribution.
Yes, sir. We can consider this could be, this is my contribution. Further, I'm working on that algorithm which I have told that to select the best optimal one. So among this one, which is from here we can visually pick from the graphs itself. But I'm designing one more algorithm in future. Means I'm still working on this one, which can pick from this one, best one.
Okay, okay. Thank you, sir.
Thank you so much. So I guess there are there are no more questions. So we'll be moving on to the next presentation. Do we have Shri Ganesh to present the paper titled Mathematical Optimization of Coil Geometrics for Position Sensors? Are you there? Are you there? Okay. So I sincerely thank our authors for their excellent presentations and contribution during this session, and all our participants for being a part of this international conference. I hope this session was informative enough for each one of you. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already been forwarded to the printer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. Before ending the session, I would also like to take a moment to thank our chair for this session, Professor Sheng, for chairing this session. Thank you so much, sir. Would you like to share a quick closing remark with us? Sir, would you like to share a quick closing remark with us?
Yeah. Okay. Yes. Thank you very much for the wonderful presentation. Yeah. I wish you all a happy weekend and see you next year. Thank you.
Thank you so much, sir. This is a token of appreciation to the chair on the behalf of whole team of ICICT 2025 and Global Knowledge Research Foundations and partners. I would also like to thank Professor Deepak Mane for chairing this session. Thank you so much, sir, for your valuable presence. Would you like to share a quick closing remark with us?
Yes, ma'am. Thank you, everyone, for your presentation, and everyone has given the nice presentation. Thank you.
Thank you so much, everyone. Before ending the session, I would request everyone to kindly turn on their cameras for a quick snapshot. Everyone kindly turn on your cameras. Thank you so much, everyone. Stay safe. Take care. Thank you. Bye-bye.
Thank you.
Next.